Curves in CorelDRAW can be as simple as a single straight line, or complex open or closed shapes comprised of curved or straight segments. In this tutorial, we'll look at what defines a curve, how to create straight and curved segments, and how to work with various node types. A curve is an object that follows a specific path which gives it its defining shape. A curve can be a straight line, an open curved line, or a closed multi-segment path. Every curve has nodes, which can be displayed and manipulated with the Shape tool. Aside from spirals, freehand lines, and lines created with the drawing tools, most CorelDRAW objects are not created as curves. Here's a rectangle, which is listed as such in the object stalker. This rectangle has nodes, which can be seen when activating the Shape tool and clicking the rectangle. But you can't do much with these nodes except change the shape of the corners. You can also see nodes when selecting the rectangle with the Pick tool. They are the tiny white squares. But again, you can't use them to change the shape. If you want to work with these nodes to change the shape, you first need to convert the rectangle to a curve. Do this by either clicking the Convert to Curve icon or by right-clicking and choosing Convert to Curves. You can also use the keyboard shortcut Ctrl-Q. Now, a curve is listed in the object stalker. When you use the Shape tool now, you can access each node individually. 3 nodes are white squares, and the arrowhead node at the start or end of the curve is a line node. A node you select turns blue, and you can drag nodes to change the shape. Using the Shape tool, you can marquee select multiple nodes. Or by holding down the Alt key, you can create a freehand marquee. Delete a node by double-clicking on it. Add a node by double-clicking along a line or curve. Select a node and press the plus key to add evenly spaced nodes along the segment. You can change the look of nodes by going to Tools, Options, CorelDRAW. On the Nodes and Handles tab, you can set node display size and colors. The 3 shapes represent the 3 types of nodes: cusp, smooth, and symmetrical. You can change how the node types are displayed by changing their icons if you wish. For this tutorial, I set the node size to large to make it easier to see them, but I'm now going to reset this back to medium. When we select multiple curves with the Shape tool, these will be displayed in different colors to make it easier to see which nodes belong to which curve. Red and blue are the default colors, but you can choose custom colors here to make it easier to see the paths when working on a colored background. If I create a copy of my curve by pressing the plus key and then select both objects with the Shape tool, we can now see the curves displayed in red and blue. I'll delete the copy and return to my original object. The square nodes of our rectangle-shaped curve are cusp nodes, which means nodes that hold a sharp corner. Let's change these to smooth nodes. To do this, we need to convert the straight segments to curves. Select all nodes on this object and click Convert to Curve. Then click Smooth Node. Now all segment transitions are smooth. In addition to moving nodes themselves, you can use a node's control handles to control curvature. Right-clicking on a node enables you to change its type, such as changing a smooth node to a cusp. For a cusp node, use the control handles to create a sharp corner. The last node type is symmetrical, which has a diamond shape. Symmetrical nodes have the same tangency and curvature on both sides of the node. Now let's take a closer look at the Shape Tools property bar. This drop-down menu allows us to choose between a rectangular or freehand node selection mode. Or, as we saw earlier, we can just hold down the Alt key to toggle between the two modes. If we don't want to just double-click on the curve to add or remove nodes, we can use either the Add or Delete Node command. The Break Curve command lets us split a path at the point of the selected node. Both ends can now be manipulated. Note that when I split again, the result is not two separate objects. To completely separate both halves, I need to right-click on the object and choose Break Curve Apart. This will result in two new paths, as can be seen in the object stalker, each of which can now be edited separately. The next two commands allow us to convert either a straight segment to a curve or a curve to a straight line. Next, we have the node selection commands where we can choose a cusp, smooth, or symmetrical node. Paths normally have a direction, as indicated by the triangular line nodes at each end of a path. Reverse direction reverses the positions of the start and end nodes. Reversing the direction of a vector path is a powerful tool in vector graphics that can influence the visual outcome of path operations, stroke effects, gradients, patterns, text alignment, and animations. For example, if a path has a stroke with an arrowhead, tapered stroke, or other directional effect, reversing the path direction will flip these effects. In this case, the arrowhead moves to the opposite end of the path. Text on a path will be flipped if the path direction is reversed. Sometimes an object can contain more than one path. These additional paths are known as subpaths. The Extract Subpath command subtracts the subpath and creates a separate object from it. Sometimes when drawing a shape, we don't quite manage to close the shape, resulting in an object that can't be filled with color or a pattern fill. Luckily, there are several ways of closing open curves. Start by selecting the two end nodes. The Join Two Nodes command will simply bring the two end nodes together to close the path. The Extend Curve to Close command leaves both nodes in their original position and joins them with a straight line. The Close Curve command joins or detaches the end nodes of the path. For more control over how open paths are connected, we also have the Join Curve Stalker. This gives us several options of how we want the end nodes to be joined, and we can choose from an extended line, a chamfer, a fillet, or a Bezier curve. The Join Curve Stalker is particularly useful when the nodes are some distance apart. For the nodes to be joined, however, we must choose the correct gap tolerance. In this case, I'll choose 20 millimeters. Stretch or scale nodes and rotate and skew nodes commands allow us to stretch, scale, rotate, or skew segments of a curve object. CorelDRAW lets you quickly align and distribute nodes in one or more curves. To do this, we can either use the Align Nodes command on the Shape Tool property bar or the settings in the Align and Distribute docker. Nodes can also be aligned to a pixel grid to prevent blurry edges in curve objects designed for web use. Let's start by aligning the nodes in this object to create a zigzag pattern. Nodes can easily be aligned vertically or horizontally using the Align Nodes command on the property bar. But this will not space the nodes out evenly. Using the Align and Distribute docker, however, allows us not only to align nodes, but also space them out evenly. In the docker, make sure that the Align Node setting is set to Active Nodes. Start by selecting the nodes that we want to top align. Under Align, select Align Top. Repeat with the lower nodes, but select Align Bottom. Now select all nodes and choose Distribute horizontally. All nodes are now accurately aligned and distributed. To align nodes to a pixel grid when creating web graphics, switch from Enhanced View to Pixel View. Select the vector object and zoom in. In the Align and Distribute docker, click on Align with Pixel Grid. Moving on with the Shape Tool property bar, we are now going to look at reflecting nodes. Normally, when we select several nodes and move them, they will all move in the same direction. However, we can also have nodes mirror each other. This can be very useful when aiming for symmetry in an object. So if we select these two nodes here and move them to the right, both nodes will move in the same direction. Let's try mirroring these now and see what happens. I'll click on Reflect Nodes horizontally. We also have the option of reflecting nodes vertically. Normally, when multiple nodes are selected and moved, all nodes move in unison. In elastic mode, the nodes will move according to their relative distance to each other. Working in elastic mode makes designs look more dynamic, but be sure to deactivate it again when you're done with it. Otherwise, the nodes will continue to display elastic behavior when selected and moved. After converting a raster image to vector objects, we can sometimes be left with objects with a high number of nodes. Generally speaking, the fewer the nodes, the smoother our graphic will appear and the easier to edit. In a later chapter of this course, where we will be covering how to convert raster images to vectors, we will be going into more detail on how to avoid arriving at vector objects with too many nodes. For now, we are just going to take a look at the various methods of reducing nodes. In this example, an image of a kangaroo was converted to vector objects, and all objects were welded together and given a single color. However, when I select this logo with my Shape tool, I can see that I have way too many nodes. Start by clicking on the Select All Nodes command. The first option we have is to reduce nodes. This will increase the smoothness of the curve by automatically deleting nodes from within the selection. But as we can see here, that hasn't really reduced the number of nodes as much as we'd like. The second option is to use the Curve Smoothness slider bar. This will reduce the number of nodes but also changes the shape of the object in the process, which is something I don't really want. Finally, we have the Smooth tool in the Shape Tool flap menu. This allows us to remove nodes more precisely. Holding down the Shift key and dragging lets me adjust the size of the nib, and holding down the Alt key allows me to control the amount of smoothing. Let's try this out. In this video, we have covered paths, segments, types of nodes, and various node commands from the property bar. We're now ready to start using the drawing tools in the toolbox, which we'll be covering in our next video.